Let's see another one. Very similar to the previous one. If you look at it properly, D1 and D2 are exactly the same. There is a resistor. I have just connected a MOS transistor. So here this was present, this diode is present, this diode is present, this resistor is present. Here I have connected a MOS transistor. So this is one variation in this circuit. And the other variation is I have connected D3 and D4 towards the supply. Now why have I done this? Is to provide additional protection at the expense of increased parasitic capacitance and a complicated geometry. But let's not get into that right now. You will see two cases here. Case 1, when this transistor is not present. Case 2, when this transistor is present. Fair enough? So let's first say that this transistor is not present right now here. And it's exactly same at the bottom. Only at the top I have connected two diodes and they are connected to the supply voltage or power supply voltage. Now let's see. Let's call the on voltage of the diode as V on. Fair enough? Now I'm going to consider the case when the transistor is not present and the on voltage of the diode is V on. Just remember that. So when a voltage at the input is applied, which is VDD plus V on, something higher than VDD is going at the gate, technically, correct, of a CMOS inverter. So what's going to happen is this VDD plus V on will be passed here. Let's see what's happening to D3 and D4 at this point of time. This is the on voltage, right? So VDD plus V on at the positive, at the negative is VDD. So this is forward biased. Same in this case here. This is also forward biased. Both of them are forward biased in this case into conduction, and the charge can be easily dumped towards the supply, correct? Some voltage drop and the charge can be easily dumped towards the supply. Fair enough. At that point of time, these two guys, diode D1 and D2, because this is VDD plus V on, right? VDD plus V on. They are both reverse biased, but they are in the range below 10 to 12 volts. So they are having a current which is 0. They are in this range, technically. So everything is happening properly, no problem at all, correct? Now let's see what's going to happen if an excessively high voltage is applied. If a very high voltage is applied, we know that these two diodes will come in the picture. They both will become excessively large, reverse biased. And because of the Zener voltage breakdown, it will divert all the current or all the charge to ground. So what I have done is, in simple words, I have connected two diodes towards the supply and I have connected two diodes towards ground, separated them both through resistors which will incur an additional voltage drop in case the need. This is supply, this is ground, and made it connect to the input pad. This is as simple as that. Another resistor also for the voltage drop. So this is case 1 which we have seen. Case 2, the presence of this MOS transistor. Now what does this transistor do is, this MOS transistor has a very high threshold voltage. So it does not turn on in the normal threshold voltages. So when the normal voltages are applied, this transistor is off and the normal voltage can pass and go to my CMOS inverter or my input stage. Now, when very high voltages are applied and for some reason we presume that the diode cannot protect our circuit, or this is nothing but an additional protection, this MOS transistor, what's going to happen is when very high voltage is applied, this transistor will turn on because its threshold voltage is very high. So it will require a very high gate voltage to turn on. And when this turns on, it will pass the current at its drain towards the source. So the current gets, or the charge gets steered up to ground. And again, this will tend to protect my circuit. So this is another way of protecting our circuit. So these are some of the ways. We can go ahead and study few more ways where we can remove all the diodes, just keep this resistor and this transistor, and we can still achieve the functionality. This is all additional protection. So what we studied here was, one protection is where you just have your diode, correct? Between them resistors is what you put. This is one protection. Additional protection we went ahead and saw was this one. Then we went ahead and saw another additional protection where you put a transistor here with a high threshold voltage. The other one could be remove all the diodes, just let the resistor and this transistor work, all different combinations of the circuit, which is used to protect our input circuit from electrostatic discharge event. So I think with that we understood input protection circuits.